Applicability of PMV and EPMV index to naturally ventilated classrooms in tropical climate by Olga Montoya and Margarita Villalobos, Universidad de San Buenaventura, Cali. Introduction. The Colombian technical norm for thermal environmental conditions for human occupancy corresponds to ASHRAE 55 that regulates comfort conditions in buildings. The NTC defines a summer comfort range between 22.5 and 26 degrees Celsius at 60% relative humidity and a MET lower than 1.2, where maximum 10% of the population is unsatisfied. The model to predict comfort is based on the predicted mean vote and the predicted percentage of the satisfied model developed by Fanger. It allows to predict the average value of the thermal sensation of the occupants and the percentage that finds it satisfactorily comfortable. According to the standard, the comfort range is between minus 0.5 and plus 0.5 PMV with PPD lower than 10%. However, the ranges established in the international standards have been questioned for being the result of research in controlled climatic conditions which do not necessarily reflect the reality. Even Fanger, the author of PMV and PPD indexes, recognized the limitation of his model in non-air-conditioned buildings in warm climates due to the expectative of people living in that climate. For this reason, a correction factor was proposed based in expectancy denominated EPMV. Methodology. Our study was carried out in Cali, Colombia, located at a latitude of 3 degrees 42 minutes north. Its climate is wet and dry, similar to the tropical savanna according to the Köppen climate classification. The study took place in 4 schools located in marginal areas. The envelope of the classrooms in materials like cement and clay blocks are permeable with blinds, openings, and windows to the exterior. The methodology is based on the environmental audit of user perception designed to analyze comfort and power efficiency of schools. It integrates objective and subjective components to establish correlations and incidences between them. The objective component is based on continuous measurements with specialized equipment during 2 periods of the year, rainy and dry. We also did punctual measurements simultaneously with the survey. The subjective component is based on surveys applied to 535 students between 8 and 16 years old. 277 of them were surveyed during the rainy period, while 258 during the dry period. The isolation of clothes corresponds to the sum of garments that conform the uniforms for the summer season, and the metabolic activity was assumed as 1.2. Students were asked about the thermal perception of the environment according to the scale of thermal sensation vote. There were also questions of the perception of ventilation and adaptation strategies to the thermal environment, such as taking off or putting on layers of clothes, open or close windows, etc. Results of both components were integrated in an audit processing system which unified all the results in an Excel spreadsheet for its processing and analysis. Specific values such as the thermal sensation votes mean resulted from the weighted average of the votes in each classroom. For the calculation of the PMV and PPD indexes, the CVE ASHRAE thermal comfort tool was used. Other values like the operative and neutral temperatures and PMV resulted from applying the equations proposed by ASHRAE. The neutral temperature is determined graphically from the crossing between the slopes of the regression lines of the mean TSV and the neutral state, TSV equals 0, and represents the ideal state of temperature at which people will be comfortable. Results. 41.5 of the thermal sensation votes correspond to comfort during the rainy period, while the mean TSV showed the distribution between comfort and discomfort by heat and cold. A 57.4% of the TSV during the dry period also ended up in comfort, while the mean TSV showed some results in comfort and some others in comfort by cold. In the rainy period, Tn under the EPMV and Tn under TSV do not coincide, one being 23 degrees and the other one being 27 degrees Celsius. This finding coincides with other studies in the tropic where Tn under PMV was lesser by almost 3 degrees Celsius. TM-PMV was similar for all the expectation factors applied from 0.5 to 0.9. On the contrary, TN-TSV is not only much greater to the one predicted under the PMV model, but that one exceeds the range indicated by the standard for comfort situation in warm climate. In the dry period, for smaller thermal amplitude of 7.8 degrees, the behavior is similar, while the Theoretical PMV shows a lower Tn PMV equal to 24.2 degrees, Tn TSV equals 25.2 degrees Celsius. In all the cases of ePMV, the votes maintain the same trend from the original PMV, displaying a greater situation of discomfort by heat, while in the TSV, almost all perceptions of students are in comfort and the few cases in discomfort are due by cold. This reflects the inconvenience of the ePMV using a constant expectation factor, similar to the original PMV. Regarding to comfort in the dry period, the votes expressed by students TSV demonstrate a greater situation of comfort related to the rainy period with greater thermal amplitude. Conclusions. The Tn under the theoretical model of the PMV were different in both periods analyzed and lower than the Tn resulting from the TSV expressed by students of schools in Cali. This difference was more pronounced by 4 degrees in the rainy period with greater thermal amplitude compared with the difference of 1 degree in the dry period, which can indicate that people is used to warm climate at higher temperatures. A greater demand or prediction of the greater situation and discomfort by heat under the theoretical model PMV is observed where most of the classrooms are in discomfort by heat in condition of TO study. This can imply an over-design of the thermal requirements and higher power consumption. The factor of expectation selection ends up being ambiguous, and even though the result when applying the factor 0.5 got close to the prediction of the number of classrooms in comfort, the trend was different. The differences between the predicted comfort and their different factors was not representative. The PMV model and the proposal of ePMV do not reflect the situation of comfort in the analyzed case studies in Cali, a city in a tropical location. It is necessary to review the indexes used to predict the comfort in this type of climates and to review the national regulation based on ASHRAE to analyze comfort in other contexts.